I'm going to show you how to answer question 5. This is the last question from the 2018 Double Award Unit 6 Physics paper. It's higher tier, it's pretty challenging, but if you break it down it is quite doable, and I'll show you how to do that today. So there's some reading to do at the top of the question up here, so if you read your way through that, we've got a table with some information contained within it, and then we've got our question. And what they want us to do is calculate how much carbon dioxide is given off if we're using 10 litres of fuel per week. So what I'm going to do for this is I'm going to have a quick read. So I know that I've got 10 litres of fuel per week, and I know how many kilometres I can do from 1 litre. So I'm going to do 10 times 31.6, which is going to give me 316 kilometres per week. And I need to find out, so I need to times that by 52 to get a year, which is times 52, which is 16,432 kilometres. And then I need to times that by the amount of CO2 given off per kilometre, which is 8.9, so 8.9, which is 1462.448. Now we don't need necessarily all of this. The exam board would be quite happy for me to round that, so I'd end up with 1462.4 kilograms. Now the next part of the question, the challenge here actually is in the words. So it says variety of ways such as inertial losses. Inertia is, you need to go back to your work on forces and Newton. Inertia is to do with how objects don't want to change what they're doing. Rolling resistance and idling losses. Now idling is what we call when a car is stopped but the engine is still running. And it wants us to say how can we reduce the energy being lost in these three ways. So inertial losses, inertia and mass are very closely linked. So I can reduce inertia losses. So I'm going to just call that IL to be quick on the video. Inertia losses, and we get a lightweight car. So making a car as light as possible. Rolling resistance, I could have smooth tyres, or properly inflated. If you run your tyres flat, so not with enough air in them, you lose quite a lot of energy. So if we make sure they're pumped up properly, that's good. And then idling losses, that's going to be IL again, that's not very helpful. Idling losses, if we can have start-stop technology, so that's where the engine turns itself off when you reach the traffic lights. So if the traffic lights run red, the car will turn its engine off for you and then back on again when you set off. We're going to turn over, so this last bit is pretty challenging actually, the very final bit, but we'll work it through. Again, it's worth 4 marks, so there's quite a lot of reward here for doing some of the various different bits, okay? So it wants me to work out how much energy is transferred into the battery. Now if you go back and read the stimulus material, it will give you some clues, but I know that any energy lost from kinetic is being given to the battery, or at least 60% of it from reading the text. So I need to work out the change in energy. So what I'm going to do is I'm going to say the kinetic energy lost is equal to the KE at 30 minus the KE at 10. Okay, so now I need to use my half mv squared minus half mv squared. Okay, so I'm just put some numbers in. So the mass of the car is 1,160 from the question, and this one is going to be 30 squared minus, I'm going to put brackets in to help make the whole thing look a bit neater, half 1160 times 10 squared. And then if I calculate that out, I'll do it in stages for you. 522,000 minus 58000. And then if I actually work that sum out, I get 464,000 joules. So that's the energy lost by the car. Now, it says in the question that 60% of the energy is turned into electrical energy in the battery. So I just need to find 60% of this. So 60 sorry, I slid off the paper. 60% of 464000 is 464000 times 0.6, which is 27840. Okay, so as you can see, it's very doable, but you do have to have some skills and you do have to think your way through the problem. I hope you found that useful, and I'll be making another video again soon.